Thanks. I'm here to talk about speaking HTTP to your database, and mostly about a project I've been working on and off for a couple years called ModNDB, and what questions came up and what I learned from them and where it's going and how they apply to other kind of projects. So the background here is MySQL cluster again, and just the quick architecture. This is where the real interest is in the data nodes. It's where your data is stored, right? To get to them, the general supported way to get through them is you go through a MySQL server. So here we've got, this is where the data is, and we put another layer on top of it for access. Then it gets even a little bit bigger than that because you put your application in. So the application writes SQL queries, talks to MySQL, MySQL parses SQL queries. Also, again, there's the NDB API. So this low-level, high-performance API, and maybe there's an application that also uses this directly. So that's sort of your basics, MySQL cluster. But then it could get bigger than that even. Maybe there's a browser that's the real user interface, and you go to a Java app server, and you're writing queries and sending them to the MySQL server. I'm working on a customer project right now that's even more layers than this, because there's opening queues, so there's messaging, and there's caching, and there's proxies. So, maybe 4 or 5 layers from the database up to the browser itself, and pretty noticeable latency, I think, when you get that big. So my idea, starting about 3 years ago with ModNDB, was to try to come up with an alternative architecture for MySQL cluster, so that you have a browser or an HTTP client that sends a request, and here's an Apache web server with the NDB API built into it, and you just go straight from this HTTP request to a efficient low-level database call and back, and take some layers out of that architecture, get the latency down, get the performance potential up. This is how I thought about it 3 years ago. If you started over with this problem today, there's another interesting way you might do it, where you've got MySQL cluster, the NDB API on top of it. You could do the same kind of thing, a web server that speaks HTTP and gets data from MySQL cluster. But you could use NDB bindings for Python, and Python web server framework like Tornado, so a multi-threaded Python web server framework, and you could put it this way. And this is kind of an interesting thing. Somebody ought to do it. I think a lot of what I did applies to that architecture too. So here's the basics. What do you want from an HTTP database? And as I've seen it, you want to do it. You've got your client. You do a GET.
Don't mind me.
That's it. You send a GET to the server, and you get back. Here we have your response code, your E tag, which is going to be important, your content type, which is JSON here. It might be XML, and it might just be text. And here's your data, right? And then here's the wire protocol for the data. In this case, it's text, it's JSON. So there's a GET. And here's a post. We're gonna, so let's see if we go back. Here was one car that we got using a car ID, right? We're gonna put a car into the database now. We're actually giving it an ID and its attributes. So the client is sending this, and the server responds. There are a couple of responses here. You can do a 204, no data. You can do 200, okay. Probably the best one is this 201 created that gives you a location of a location for a get for the thing that you just created. And I mentioned that e-tag. I think one thing here that really has potential beyond what you can do with the wire protocol of MySQL or of any other database server is that HTTP 1.1 really understands caches and proxies, right? You know, here's your origin server, West Coast. Here's your proxy in Europe. Here's your browser, and here's that e-tag. We you know, the if value match, and here's the tag of a cache result. And if that tag is still valid, then the origin server can just tell the proxy, hey, that tag is still valid. All of the big data that you have, you can send it forward to the client. Right? Or with a put. Now, so post is widely implemented. Put is not so common. I think the standard is a little more strict about put because it wasn't so deployed, and the standard could come out, the HTTP standard could come out and say, here's how put would work, right? And with put, if the client updates the record through the proxy, then HTTP tells the proxy to expire its old version of the record, right? So the proxy passes the update on to the authoritative origin server, and meanwhile expires its own old copy, right? So when I go back there. All right. When I started on this, here's a simple problem you solve: is you've got a URL like /app/car. You have schemas and tables and columns in your database, and you just have to define a mapping, right, between the URL and the data structure. And so, what does the URL mean? Right? What is the security policy? And when I started out with this, I said, oh, that's simple enough. Here, I've got an Apache configuration file, and I'm just going to define that stuff, you know, the way you define configuration in Apache, right? So, okay, what's the schema? So, here we've got /db/app/car. We're going to take everything under /db/app. So here's a location container in the Apache config. We're going to map this. So we're going to get a database bracket, map it to a schema. All right. And then, so that was top level. This is /db/app, right? And then we're going to go one level down. So db/app/car, and we're going to have a location container for this in point 2, and we're going to map it to a table. All right. So straightforward so far. And then there's some security stuff. Maybe this web server carries who you are for certain operations, maybe not for others. That was easy enough. There are already Apache modules that do this for me, right? So I'm going to throw in a required knowledge user, and the whole rest of the Apache web server infrastructure comes to work and starts, you know, authenticating and authorizing for me. Okay. Then let's see. when you hit this endpoint and you want a record from it, do you get every column, or maybe there are columns I don't want to send you, right? So I throw in a columns directive that's going to define the columns that you get. Okay. So far, so good. And then another one comes in. So say you're doing a post. Do I want to let you write all the columns you create, or maybe just write only some of the columns you create? So I throw in another directive. And here's our allow update and RID tax date. In this case, you can update all of them. And at this point, you know, I have a real job too. I drop the project for a few weeks at a time and come back to it, and I noticed that I came back to it, and I already had so much configuration language that I couldn't remember it. So I said, what you really need to do is to put a SQL query in the Apache config file, because here SQL is a language that already answers all of those questions that I was talking about for the mapping. So I said, okay, there's a standard way to define this stuff. It's a language called SQL, but I didn't go all the way there because you know there's this idea that this is always going to be a high performance API, and you don't want. Well, so developers are stupid. If you let them write SQL queries, you'll end up with a bunch of table stakes. I didn't want to do that. I didn't want to overdo it. Thank you. My pleasure. I'm very good. So I created this language that kind of like SQL, but it required you to define the access path to the data. So here's an example primary key access. So, and these are actual queries out of the test suite now. Select star from curve to where primary key equals right, which comes out of the query. And then we've got a two-part primary key. So primary key, same thing, select whatever from the table. Where primary key equals the first part, second part. Or a unique index. So select A from column 0. This is a table name right here, strangely enough. Where, and then I said where, so we're a unique index, and here's a two-part unique index. So where unique index, blah, that's the name of the index, equals part 1, part 2. I did a similar looking thing with an ordered index scan, so select A from column 0 using ordered index, that's the index name, where C equals this parameter and E equals that parameter. And this is the language. So the released version of MonDB is 1.1. It's on Google, so mod-ndb.googlecode.com. This is the language you get right now in the release. It's almost like SQL, and it's just different enough to be confusing. So after a while with that, I decided that wasn't the way to go either. So I concluded, so wipe out the offensive part of here. There's a standard way to define this mapping from an endpoint to your database, and it's a SQL query. And by the way, it's a compared statement. It's, you know, I still believe that it's something that you know, you define early on in this, and not so much at runtime, right? And so I'm going to do a quick demo here, and my laptop just crashed right before the talk, so I hope everything's running. I sit here. So this is a download out of the trunk. I just ran a configure command. I'm going to do make. The make is pretty quick because there's not really much to this. If I do a make start, then my log up here ought to tell me I'm connected. And here's my test suite. So we didn't make, we're passing all the tests. And now I'm going to do something a little bit different. I'm running it in single user. I'm running Apache as a single thread here, and one of the applications I created in MindNDB is a code coverage test for the code itself. You know, one of the things with code coverage is you've kind of got to correlate all the data somewhere. And I had real specific questions, like real particular points, like am I exercising this data type in this function and this data type in this function? Background that. Let's see. And I'm going to see, so my Apache kit is here. I am gonna. Okay, so I'm running the test suite again, and this time I've got some code coverage stuff going. And here I just ran the application and collected some tracing points out of dtrace and wrote them out in JSON. And I'm going to copy them. And I'm going to pipe them in to Apache. And these bad requests were blank lines, but for the most part here, I piped in a line like that, and I got back a 200K. And then I'm going to do this one other thing here to examine the source code. See, I did this. I kind of grubbed my source files to get all the coverage points to see if there was anything I didn't hit. And I piped those back into the database. I got a few responses like this. 409 conflict. I also got a couple. And now, let's see. This command. I can see. So now I've got my code coverage data in the database, using curl to get it out. That's the little command I just ran is really a HTTP localhost 3080 NDB test code cobalt, right? So I'm getting that page out. If I want to see the points, the functions and data types that I still haven't tested thoroughly in the test suite, run a little query and I get that. So that's a very quick demo and application of MongoDB. Sort of sidetrack here, and so there's a parser generator called Coco LR, and let's see, so I wrote the parser that we just saw running here. Coco is very nice. It defines the scanner and the parser in the same file. So I also wrote the JSON parser using the same tool, which is essentially, you copy the grammar off the home page of JSON.org and it compiles. And then you've got a little bit of encoding to take care of. So I created this NSQL parser with Coco. And then Talibek here, at the Summer of Code project, started working on a real SQL parser that also uses Coco. And so that's getting merged in. So here's one of the awkward things that's not solved. So HTTP has verbs, get, post, put, and delete. SQL also has verbs, insert, update, and delete. Okay, so it's pretty easy to say that a get just kind of implicitly maps to a select, and then delete kind of implicitly maps to a delete. A post can be an update or an insert. The HTTP standard is really loose about what a post is. A put can also be an update or an insert. The standard is stricter. There's this difference in what the URL means is the main difference between a put and a post. This is a little awkward, and I think it might always be a little awkward about whether a put is an insert or a replace or an update, or whether you should get back that 409 conflict. This row already exists or not. So the conclusions. There is a good way to do this still. It is SQL as the language. There's more kind of architecturally that I think the project ought to do. You ought to have SQL functions. You ought to be able to load them as modules and let Apache do that for you. Right? So Apache is already really good at loading a module. So define your SQL function as a little Apache module, and Apache will load it in, and you can use it.
Wouldn't it work with like HTTPD?
Yeah. What's that?
With the like HTTPD.
Oh no, would it work with another web server besides Apache? No, it's very specific to Apache. Yes.
My brain is sitting here thinking, what about the Memcache client protocol?
Yeah, absolutely. So you ought to be able to, you have a Memcache module, and just have a little hook in there with a Memcache update and a Memcache put and a Memcache delete function, and just very seamlessly go between them. Memcache, Gearman.
Has anybody done anything like that yet?
So, no.
Because you could have something that would work like a persistent type cache.
Right. And in fact, a get comes in. Maybe you go to Memcache first, and if it's not there, you go to the database and you return it to the client and you put it in Memcache. Right? I think that I want to create the hooks for that. They're not there. You know, I think they ought to be there. The other idea here is that really just a C API or a C++ API that looks like JDBC, that essentially lets you prepare a statement, run it, get the results. That whole API is still a good idea too. And if you do that in C, then you can map it to PHP and any other language that's running in the web server. And I know this is sort of recreating the Java application server framework in Apache and the web stack. But I think it's the right thing to do with this too. So anyway, today release 1.1 has the NSQL language, has output for JSON and XML and custom formats in a very terrible language, but it does the job. JSON request, which is this proposal, it's kind of an alternative to XML RPC. You can go back and forth between MongoDB and PHP using Apache nodes. It's not a formal API, it's kind of awkward, but you can do it. Right now I've got post support, but not good general purpose put. And then there's the SQL branch that has the new SQL parser in it. The trunk that I was just looking at is mostly 1.1 with just a little bit of new stuff. So I think the future here is standard SQL, a real optimizer, a JDBC looking API. Application could be Apache modules that use the API. SQL functions are also implemented as loadable Apache modules. Hooks and other modules like Memcache. And then let Apache manage all of this already. Because Apache can load modules, unload modules, give you filters. So, thanks a bunch.